I'm just finishing up another little project, and the project I've been working on now is a power unit. This is one of the original CB power units from back in the day, and I thought, well, I'm renovating all these various radios. I thought, let's try and sort out one of the original power packs, and this is original for back in the day. But it's possibly a little bit safer than some of them because it's a British made one, as you can see. So we hope it doesn't have the problems of some of the Chinese ones, I presume they were, the various safety problems. But it's still not perfect. It still had its snags. It has got a proper on-off switch here, which is in the live lead. That's a good thing. I don't like the slider type switches because I don't think they were really built to handle 240 volt mains, but that's what they use on them. So we've got a proper switch, we've got a red light which will come on to prove it's working. But one of the snags with this one, see, I've got these terminals on here now that we're familiar with, but it didn't have these. Originally it had just these two banana sockets, red and black banana socket, which is okay if they're used properly with banana plug, but myself, I wouldn't have used a plug on them necessarily, because if I wanted to try out a radio and I've got these kind of terminals, sometimes I'll just strip the wire a little bit, bend it over and just shove it in the hole in the front of the connector. And that's what I would have done with these. I would have just bent it over and pushed it in the hole if I didn't have a handy banana plug to solder on. The only snag is these are open. These are open. If we can prove it with something, I don't think I've got anything thin enough to put through it at the moment. But if you got your wire and pushed it into this, it could come out the other side. Can we find a spotter wire or a thin screwdriver? Thin screwdriver. Put it in and it will come right through. So that to me was potentially dangerous because I could shove my wire in it to make a connection, and I never pushed it in too far. Goodness knows what that wire would be making contact with inside the power unit. So I decided that wasn't the safest option, so that they came off and I replaced them with proper terminals, which you can still shove your wire in the end or a banana plug or whatever, but it won't go straight through, it only goes so far and stops. So that was one of the first jobs, was to replace those, which I considered dangerous. And of course, before I could apply any power on it, because this is an original and it's never been used, it's been all sealed up and left since what, the 1980s. And so I didn't want to chance putting power on it, because there's a very good chance that the electrolytic capacitors would have failed, exploded or done some damage internally. So I replaced the electrolytic capacitors, and while I was doing them I replaced them with better ones of a higher voltage working. The ones inside had a 25 volt working voltage, which was enough, but I quite often go for a slightly higher voltage for two reasons. One is it improves the safety, your margin of safety, but the other reason I do it is that they're bigger, because as time has gone on, in 40 years since these things were made, components have gone smaller. So if you get a 25 volt capacitor and replace it with another 25 volt capacitor, the one you replace it with will be very, very small compared to the original. So if you go for a higher voltage, 25 or 50, 35, 50, something like that, if you go for a higher voltage, it's more likely to be nearer to the size of the one that you take out. But we're just finishing this up. Now we're going to do a little bit of controversy. I've got to put a fuse in it. Where's my little screwdriver? I have to put a fuse. Now this will get controversial. The pack testing people will get upset about this, because I don't believe in large value fuses if you don't need them. I mean, this little lamp on my desktop, has got, it says on it it's for a LED bulb, and fair enough, it's got an LED bulb in it which is 5 watts. Well, if you've got a 5 watt bulb, there's no way that you can put a 3 amp fuse in, which is what the pack testing guys would do. You put a 3 amp fuse in, which is good for 750 watts, to power a little table lamp that only draws 5 watts. I mean, you just can't do it. There's been a lot of wrong information passed around amongst the pack testing people with the books that you get and the various courses, and they tend to teach people that you only have 3 values of fuses: 13 amps, 5 amps and 3 amps. And I've even seen quoted recently that you have this 700 watt figure, and if the power consumption is less than 700 watts you put in a 1 amp fuse, and if it's more you put a 5 amp. So I mean, that is ridiculous. A 3 amp fuse for a lamp that draws 5 watts. So I'm putting in a 1 amp fuse. And before all the pack testing people jump up and down and start contacting me and saying, oh, you can't do that, mate, you can, because all the regular information about pack testing, as I've mentioned, gives you 3 values of fuse: 3, 5 and 13. But by hunting around on the test site for the City and Guilds, they actually mention in the small print, because they're coming to the senses, that if something is using a lot less power than, I can't remember the exact quote, I'll pin it on this video, but if it's using a very low amount of power, it is permissible to use a lower value fuse than the 3, 5 and 13s. And so therefore you can do it. It's on the City and Guild website, but it's not generally known by the pack testers. They still believe that you should use a 3 amp fuse, but no way. So here we go, a 1 amp fuse going in, and we'll see what happens. We will try a bit of pack testing. That's luck, isn't it, that the screw I needed was stuck on the end of the screwdriver. So here we have the power unit, and here we have our pack tester. So this is obviously a class 1 device because it's a metal case, but I think we'll do it as a class 1 IT, so we won't be banging 20 amps down it. This tester will put, because it's a mains operated pack tester, therefore it will do a lot more than the battery ones, and more consistent high currents, which you struggle with a battery one. Obviously you can't draw 20 amps out of a battery pack tester, well, perhaps only for a microsecond. Well, there we are, it's working now. It's just a case of not getting a proper connection. By holding that down now, everything's passed. Just the insulation. Resistance is 0.04 of an ohm. And greater than 20 meg ohms insulation. So, there you are. It's me being lazy, not holding it down and getting a proper contact. So there we have it. We've passed we've passed the pack test now. Just me being lazy, not not trying to putting a proper connection. But on that screw there, we're getting a good earth continuity, we're getting the insulation, everything is passing. So it's passed its patch test. The other interesting item will be to check the voltage coming out of it. So we'll now plug it into a proper main supply and see what happens. Switch it off. Switch on. There we are, 14.6 volts. I'll see what happens when I put a CB radio on it later. But it's all working. It's passed the safety pat check. We've got a 1 amp fuse in it. What more can I say? The fact that I failed to get a decent connection with the pat tester shows that there's no fake about this. That I was doing it live for the very first time on this thing, and that was the results we got. So there we have it.